Hello everyone. This question has been taken from Olympiad Pathfinder, Ch.2, MCQ, multiple choice question number 12. Consider three identical massless springs. The left ends of the first, second, and the third springs are affixed to a wall to a block of mass m placed on a horizontal floor, not frictionless, and to a block of mass m placed on a horizontal frictionless floor respectively, as shown in the figures. Figure 1, Figure 2, Figure 3. The right end of each spring is pulled by a gradually increasing force F. Gradually increasing force. When magnitude of the force becomes F, extension in these springs become x1, x2 and x3 respectively. Which of the following statements is correct? So this is mass m, this is mass m, this is friction. This surface is having friction relative to the block, and this one is frictionless surface. These are the three figures. This spring is connected to wall. This spring is connected to this mass and on a friction surface, frictional surface, and this spring is connected to a mass on a frictionless surface. F is the force which has gradually been increased. Okay. When the force reaches to a value of F, capital F, the extension in these springs are x1, here x1, this becomes x2 and this is x3. So the question is asking which option is correct. So we will have to analyze the situation. So let us make free body diagram from figure 1 of a spring. Free body diagram from figure 1 of spring. This spring is stationary. You know by Hooke's law that x1 is the stretch in it, so this force will be kx1. No acceleration, acceleration 0. So from here you can write NLM, from Newton's law of motion. If this is the x-axis, this is your y-axis. So summation of Fx is equal to mass of the spring, which is 0, acceleration of the spring in the x direction 0. This is F in the positive x direction, kx1 is acting in the negative x direction, so this will become 0. So F is equal to kx1. So we have one equation, F is equal to kx1. See, all springs are identical, means their spring constants are same, k is same. It is given identical massless springs. Important points are highlighted. So this is number 1 equation. Now free body diagram FBD from figure 2. Of the spring. This is F. This will be Kx2. Let this mass was moving on this frictional surface with an acceleration a1. So this spring was also moving with acceleration a1. Again Newton's law of motion, so you can just write x-axis is this direction, y is this direction, the same as the summation of fx will be mass of the spring into acceleration, but mass of the spring is 0, so into acceleration, so this one will be 0. So again you got F is equal to Kx2 from here. This is your number 2 equation. Let us make free body diagram from figure 3 of spring. F stretch in it is x3, so this will be kx3. Let us assume that this mass started moving with acceleration a2 in the x direction. So this one was also moving with a2. Okay, so we will write again the force equation, then from Newton's law, summation of external force in the x direction, mass of the spring into acceleration, that is a2, 0 into a2, because the spring is massless, 0. So therefore F will be equal to kx3. This is number 3. So from 1, 2 and 3, now from equation 1, 2 and 3, kx1 is equal to kx2 is equal to kx3. Therefore k is common, is a constant. So this will be x1 is equal to x2 is equal to x3. So this should be your answer. So option A is correct. So option A is correct. Hopefully there is no doubt in understanding at any stage. If at all any, please write in the comment box. With your doubts, I will clarify. Thank you.